Hello everyone, today we will compare the computer architecture of modern processor from two different vendors in terms of memory. Introduction. Modern processors from different vendors have varying architectures when it comes to memory. Memory architecture plays a crucial role in determining a processor's performance and capabilities. In this presentation, we will compare the memory architectures of processors from two different vendors. Vendor A's memory architecture. Vendor A utilizes a unified memory architecture where both the CPU and GPU share the same memory pool. This architecture allows for efficient data sharing and reduces the need for data transfer between different memory types. The unified memory architecture of Vendor A processors enhances performance in memory intensive tasks. Memory A Vendor A memory hierarchy. Vendor A processors feature multiple levels of cache memory, including L1, L2, and L3 cache. The cache hierarchy helps minimize the latency of memory access by storing frequently used data closer to the CPU. The memory hierarchy of vendor A's processors improves overall system performance by reducing memory latency. Vendor A's memory bandwidth. Vendor A's processors employ advanced memory controllers that support high-speed DDR4 memory. These memory controllers allow for increased memory bandwidth, enabling faster data transfer between the CPU and memory. The high memory bandwidth of vendor A processors enhances the overall system performance, especially in memory-intensive applications. Vendor B memory architecture. Vendor B utilizes a split memory architecture where the CPU and GPU have separate dedicated memory pools. This architecture allows for efficient parallel processing in tasks that require simultaneous CPU and GPU operations. The split memory architecture of vendor B's processors provide better memory isolation for improved performance. Vendor B's memory hierarchy. Vendor B's processors also feature multiple levels of cache memory similar to vendor A. The cache hierarchy of vendor B's processor help reduce memory access latency and improves overall system performance. However, the specific cache configuration may differ from vendor A depending on the processor model. Vendor B memory bandwidth. Vendor B processors incorporate advanced memory controllers that support high-speed DDR4 and GDDR6 memory. The support for GDDR6 memory enables faster data transfer for graphics-intensive tasks benefiting GPU performance. The memory bandwidth of vendor B's processor is optimized for both CPU and GPU operations, enhancing overall system performance. Comparing memory architecture. Vendor A's unified memory architecture provides efficient data sharing between CPU and GPU, ideal for general purpose computing. Vendor B's split memory architecture offers better memory isolation, suitable for parallel CPU and GPU processing. The choice between the architectures, depending on the specific use case and workload requirements. Memory architecture consideration. When choosing a processor, consider the workload's memory requirements and how the memory architecture aligns with those needs. Evaluate the trade-offs between unified and split memory architectures, such as data sharing, memory isolation, and parallel processing capabilities. Additionally, consider the performance of the memory hierarchy and memory bandwidth to ensure optimal system performance. Conclusion: modern processors from different vendors exhibit different memory architectures, each with its own strengths and trade-offs. Memory architecture influences performance, data sharing, memory isolation, and parallel processing capabilities. Careful consideration of memory requirements and workload characteristics is crucial when selecting a processor for specific applications.